Good morning, everyone. Myself, Mrs. Monica Nancy Priya, Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling basic electrical and electronics engineering, and the subject code is WE25C01 in the regulation of 2025. In this presentation, we are going to discuss about basic laws of electric circuits. In this session, we are going to discuss Ohm's law and Kirchhoff's current law. So we are going to see about the basic electrical laws. In this, there are two laws. In the basic laws of electrical circuits are gone by some fundamental laws which help us to analyze circuits, calculate voltage, current, and resistance, and used to solve the real-time electrical problems. So the two most important basic laws are Ohm's law and Kirchhoff's current law. What is Ohm's law? The Ohm's law states that the voltage across the resistor is directly proportional to the current flowing through it, provided temperature and physical condition remains constant. Only the temperature and physical conditions remains constant, the voltage is directly proportional to the current. So we are neglecting the proportional. We are adding that V is equals to IR. Nothing but V is the voltage in the unit called volts, and the I is the current in the unit called amperes, and R is the resistance in the unit called ohms. In this we are having that the current flow towards the resistors in the positive to negative. So V of t is equals to R into I of t. In this, the current flows the opposite to that of the resistor, that is the negative to positive. So we are having the formula like V of t is equals to minus R into I of t. This Ohm's law having a linear relationship. The term directly proportional means if the current increases, the voltage also increases. If it in this x-axis we are having a current and the y-axis we are having the voltage, if the current increases, the voltage also get increases. If the current decreases, the voltage decreases. This relationship forms a straight line graph between the voltage and current. However, this straight line relation is valid only for real resistors and not for all the devices. Under all operating condition, this is a straight line graph, and the resistor is a model which will not produce a straight line for the all conditions. Then about resistors and the resistance, the unit of resistance is ohms. The resistor is an electrical component that opposes the flow of current. So if we want to oppose the flow of current, we should add the resistor. If we want to oppose the flow of current in large number, so that we are adding the more number of the value of the resistor is high. So the unit of resistance is ohm. The resistance, which is always depends upon the length of the conductor, the cross-sectional area, and what materials are used. So that the mathematical expression for the resistance is R is equals to rho L by A, which is L is nothing but the length of the conductor, A is nothing but the cross-sectional area, and the rho is nothing but the resistivity. In that, the conductance, its unit, the reciprocal of resistance is called the conductance. So which is what is the unit of the resistor? This is ohms. And what is the unit of the conductors? It is mhos, because the reciprocal of ohm is the mhos. So we remember that the resistance as the unit of ohms. The reciprocal of resistance is conductance. At one time, the conductance commonly had unit of mhos. Earlier, the unit of conductance was mho. The high resistance, it have a low conductance, and the low resistance, it is have a high conductance. So the reciprocal, it is the meaning of the reciprocal. G is equals to 1 by R. G is nothing but the conductance. Then we are having the one problem, that is we are having the voltage which is 115 volt RMS, that is AC circuit, AC supply, and which is connected to the resistor with the power of 100 watt light bulb. Determine the resistance of 100-volt bulb. So what they are asking? They are asking the resistance value for the 100-watt bulb. So what is the formula? What is the power formula for power? The power value of the formula for power is the product of voltage and current. So it is called the power. So we are having the formula as P is equals to VI. In terms of I, we are having what is the Ohm's law formula? V is equals to IR. In terms of I, we are having V by R. So V into V by R is equals to V squared by R. In terms of what is V is equals to IR? We are substituting V is equals to IR in V, so we are getting I squared R. So what is the value? P is equals to VI. So it is called V squared by R is equals to I squared by R. Okay. Then what we are having in this power equation, in this power formula, we are having voltage and the power. So what formula we are choosing? P is equals to V squared by R. So we are having R is equals to V squared by P. So V, what is the value of V? 115. So 115 squared divided by what is the value of P? What is the power in the value of resistance? 100 watt. So we are substituting 100 in terms of power. So what is the resistance value? 132.25. So we are having the value of resistance is 132.25 ohms. What is the unit of resistance? Ohms. Then this is the property of resistance. The resistivities of some basic materials. These are the material which are used in the resistance: silver, copper, aluminium, gold, carbon, germanium, silicon, paper, mica, glass, Teflon. In this, we are having conductors. What are all the conducting material? Silver, copper, aluminium, gold. These are all the conducting material. What is the semiconducting material? It is partially conducting. What is that? Carbon, germanium, silicon. And what is the insulating material? Paper, mica, glass, and Teflon. These are having the different resistivity values for the each material. Then in this, the Ohm's law, which is the electromotive force. Under the influence of an electromotive force, the one valence electron of each copper atom is pulled from the outer orbit and moves through the copper space towards the positive potential. In this, the electron flows the opposite to the positive. So that what is mean that the current flows, the flow of electrons is called the current. Under the influence of an electromotive force, the one valence electron of each copper atom is pulled from the outer orbit. These outer orbit are all pulled towards the copper atom. This is Kirchhoff's current law. The second one is Kirchhoff's current law. As a consequence of the Kirchhoff's current law is based on the law of conservation of charge. The algebraic sum of current at a node is zero, or the sum of current entering a node is equal to the sum of the current leaving through the node. Here, this is the node. This point is the node. The sum of current entering. What are the currents are entering? IA is entering. Then IB is entering. So we are having the formula IA plus IB is equals to, these are the sum of the current leaving away from the node. Okay, so IC is leaving away from the node, ID is leaving away from the node. So we are having the formula towards the node is equals to the away from the node. Towards the node is IA plus IB, and from the away from the node is IC plus ID. So IA, IB, IC, ID can each be either positive or negative number. If it is IA is negative, means in this we are having the algebraic sum of current entering a node is equal to 0. The sum of entering the node, what is that? IA plus IB. So we are having IA plus IB. Then is equals to, here also sum of entering the node. So IA plus IB minus IC plus ID. Positive negative is not not at all a problem. So we are having the IA, IB, IC and ID can each be either a positive or negative number. So we are having the formula equation like IA plus IB minus IC plus ID equal to 0. So to conclude, what is the Ohm's law relates voltage, current and resistance, whereas KCL helps in analyzing complex networks. These laws form the foundation of electrical circuit theory. Understanding these laws is essential for circuit analysis, electrical machines, power systems, electronics. These are all the topics that come under one by one. Thank you.